Hi students, coming to the next topic, that is the shortest path problem. So actually there are two types of shortest path problems. So one is Dijkstra algorithm and another is Bellman-Ford algorithm. So these two algorithms, the Dijkstra algorithm and the Bellman-Ford algorithm, both solves the single source shortest path problems. So these two algorithms will solve the single source shortest path problems. Okay, so the shortest path problems are of two types, Dijkstra algorithm and the Bellman-Ford algorithm. So both are useful for solving the problems that are occur in single source shortest path problems. So that should be a directed, let us start with, take Dijkstra algorithm. Dijkstra's algorithm. So this Dijkstra algorithm, solves a single source shortest path problems on a directed. So this is based completely on directed weighted graph. So the one thing you have to be noted that Dijkstra algorithm is completely based on the directed, directions will be there, a directed weighted graph of G consisting of vertices and edges. So where all edges are non-negative. So whatever the edges that are present in the Dijkstra algorithm, that should be non-negative. Whereas in Bellman-Ford algorithm, you can include the negative edges also. But the difference between these two is Dijkstra algorithm have the edges which are non-negative numbers, whereas Bellman-Ford algorithm can accept the negative number edges also. Okay. Now let us see this algorithm of Dijkstra algorithm. What is the algorithm? Let me write the algorithm of this method. Algorithm Dijkstra's algorithm. G is the graph, W is the weight of that edge, and S is a set. For each vertex belongs to the graph. So that vertex should present in the graph. So V dot D, first starting it should be initialized to infinity. It should be nil, and S dot D, the distance should be 0, and the starting S should be indicated 5, and the Q, whatever the Q, that should be G graph dot vertex. So here the condition, first simply I am writing the algorithm, afterwards I will take the example how we will solve the Dijkstra algorithm to find out the shortest path. Extract min of Q means the extract min is a function which is extract the minimum edge that is present in the graph, that acts as a key, that acts as a sample key. Extract min. S is equal to union of, you have to combine that extract minimum value with the set. For each vertex, V belongs to G dot edges of U if V dot D is greater than U dot D plus W of UV. So these are the edges, okay, for that vertex, and that should be, this weight should be greater than the vertex dot D. Then you have to take V dot D is equal to U dot D plus W of U comma V. And finally you make V dot pi is equal to U. So this is the algorithm for the Dijkstra method. Now let us take the example. So here this is an example. This is a graph So let us consider the vertex 1 and the 9. We have to reach from vertex 9 to 1 to 9. As a start, this is a start, and this is the destination. So in the previous algorithm, I said S is for the start, the set. S is start, and D, it should be destination. The vertex of the destination should be, make it as an infinity. Okay, and the starting vertex, the start dot D should start with the 0. Okay, so this is the start and this is the destination here. So the vertex, destination was vertex respectively. Initially all vertices, so whatever the vertices is there, initially all vertices except the start vertex are marked as infinity. So here I marked except the start vertex. So this is the start vertex. Except the start vertex, I make all the vertex or infinity. Mark it as infinity. So next, and the start vertex is marked as 0. So now we have to be checked for vertex from starting from the vertex v1. So the edge we have to take the 5. It reaches to the 2. Okay. So here we have to find the minimum distance of vertex 9 from vertex 1. So what will be the minimum distance? So we have to be calculated by checking the each vertex. Okay. So this is all comes for the vertex 1 to 9 is the vertex. So step 1 from vertex v1. So starting it is initially it is 0, marked as a 0. So the edge it has taken the 5 to reach to the vertex 2. To reach to the vertex 3, it has the edge it has taken 2. So the 5, 2. And the remaining all mark it as infinity. Now coming to the vertex v3. Okay. So coming to the vertex v3. So starting the vertex 2, it has to mark it as a to reach to that vertex, we have to mark it as a, the vertex is a 4, and here the edge is coming to the 3, and here this vertex it goes to 2. So like that we have to be calculate the step 1, first v1 vertex, step 2 v3, step 3 v2, means it's going like that. Okay, so this is vertex 1. This is 1, 2, 3, 4, 5, 6, 7, 8, totally 9 vertex are there. Okay, so first it goes to 1, from there to v3. So this is v3. So v3 to again it's checking, it is going to v2. Okay, so after that it going to v4. So v4 to v5, it is going to v5, v5 to v7, v7 to v8, v8 to v6. Okay, finally the last one should be, all should be the infinity. Okay, so like that it is checking each and every vertex and seeing whether that vertex contains what is the edge of that value of that vertex. So like that we will mark the chart like this. So hence the minimum distance of vertex 9 from vertex 1 is 20. What is the path then? 1 to 3, 3 to 7, 7 to 8, 8 to 6 and 6 to 9. So what is the total? 2 plus 9 plus 2 plus 3 plus 4 is equal to 20. So the minimum distance from vertex 1 to 9 is the 20. So this is about the Dijkstra algorithm. Thank you.